just continue, and people will come in and out of this session as they are writing other things. Okay. So basically, we're starting with study unit 1. We're looking at some of the assignments that you guys did, some of the questions that was sent through, and we'll work with that. But please also, like last week, interrupt, ask if there's something that you don't understand, that we need to explain or need to look at. So I think, again, this is more a working together session, so please interrupt me if there's questions that you want to ask around certain questions. Okay, so we're basically starting with the study unit 1. And let me see if I can just, so I think what we also need to, as we go along, I'll just add things that might be important or to look at as well. So in study unit 1, that's basically where we start with stats. We look at things that are part of a sample, things that are part of a population. So for me, when I look at something like this, I always look at that a statistic is to do with a sample, and for me it's just, and the parameter is to do with a population. So that's just for me always how I remember it, because I can very in a lot of the questions they can throw the two terms together and make one confused. But for me, always this S in front of a statistic matches the S with sample. So that's the two that goes together. So in this question, which one of the following statements is incorrect with regard to a statistic? A statistic is an estimate of a population parameter. So that is correct, and that is why you always, when we get to the study unit 6 and 7, that is where we always have the parameters of the variance and standard deviation and mean. And normally we'll say if it's unknown, we don't know something, and that is all to do with if we have the information of a population parameter. A statistic represents a property of a population and not that of a sample. Of a population, no. Okay, so we have a link, yes. Question? Or was it just, no, okay. So basically, a statistic represents a property of a population. No, that's incorrect, because a statistic represents the property of a sample. A statistic is so the rest will be correct, but let's just look at them. A statistic is a summary measured, calculated from a sample. That's correct, because sample standard deviation is a statistic. That is correct. And the sample mean is a statistic. That is also correct. Okay. So the first one was nearly looking at population and looking at sample, and the parameter always goes with a population. The sample always goes together with a statistic. Okay, so that is basically that first concept that we've learned in study unit 1. But then you could also see nearly in the last part of this question how we nearly moved on from that and what we've started using in study unit 6 and 7 around the sample means and things like that. Okay, questions around the population and the statistic. Else we can just move on to the next one.
I'm happy.
Yes.
No, I'm happy. I just noticed that in my
Christina.
assessment, A was my incorrect option because they had a statistic is not an estimate. But yes, this makes more sense now.
Am I not hearing anybody? Can somebody quickly, can you guys hear me?
I can hear you. Can you hear me?
Yes, we can hear you.
In the text, because now it seems I can't hear anybody. Okay, cool. So let's go on. If at any time there's something, just type in. I am also reading the messages. Okay, so that was basically the first one in study unit 1. Also, we're still waiting for how your exam will be set out, but it is nearly 2 questions per study unit. Just to make you also, in a sense, so it's 2 questions per study unit, so that gives you around 22 questions, and then normally that sections of 6, 7, and 8 sometimes have one question for each of them more than the rest. But that is nearly how it is set out, and your exam will be such that your first 2 questions will be study unit 1, then study unit 2. So it will move in that sequence from the beginning to the end. It's not a mix match of questions during the paper. It will be basically be from study unit 1 up until study unit 11. Okay, so the other part of study unit 1, 2, and 3 is looking at now that we have a variable, we basically need to explain the variable a bit more. So which one of the following statements is incorrect? And once again, you can see they use incorrect a lot in all of our assignments, and they will do that probably in the exam as well. Okay, so with these ones, we need to nearly read through the whole question. There's not anyone that I can nearly identify and say, no, it's something that we can take out. So let's look at it. Quantitative variables takes on values with equal units, numeric values that indicate how much or how many. So do you guys agree? Don't you agree? What do you think about that one?
That's correct.
Okay, so quantitative, remember quantitative variables can be discrete, continuous, ratio. So quantitative variable takes on values with equal units, numeric values that indicate how much or how many. So that is correct. Variables can be classified as categorical or numeric. Okay, so remember, categorical is also the same as qualitative, and then your numeric is also the same as quantitative. So just to remember those two, so that is also correct. Quantitative continuous variable results from counting attributes of an element. Okay, so let's say incorrect. So incorrect continuous or continuous because you are measuring something. So that is wrong. Let's just Christina, sorry, I can't. So that's why I thought nobody can hear me as well. I don't know what is happening with this today, because I think I couldn't hear somebody else as well. So I'll sort out this link later on for the next of the sessions that we have next week and following again. Numeric variables can either be discrete or continuous. So again, let's just remember numerical is also called quantitative. So it can be discrete or it can be continuous. So that is correct. And qualitative variables uses labels or names to describe attributes. Remember again, qualitative is something like male, female, anything like that. So it basically is describing via names the attributes. So that is also correct. Okay, so this was still in study unit 1. So it again, nearly the next thing that they haven't asked is around the levels of measurement in study unit 1. And so that is between nominal and ordinal. So that is nearly, if I look at this one, there's nearly 3 types of questions that they can ask us in study unit 1. And that is on a bit of the definitions, the differences between population and sample. They can put in a few things of statistics and parameters. Then the next question can be around the types of variables, and then so there's actually, and then the third one is adding the scales or the levels. So you will see now they've added the nominal. Somewhere they need to add, probably there's for ordinal as well. So this is basically the third type of question that they can ask in around the study unit 1. So it's basically the definition, then it is types of variables, and then levels of measurement. Okay, so probably again incorrect. Which one of the following statements is incorrect with regard to variables and the scale of measurements? Okay, so a nominal scale of measurement is the weakest form, while a ratio scale is the strongest form. Okay, so this is definitely correct. So nominal is just looking at categories of data, where it can be, say, we look at the different provinces in South Africa, and 1 is Gauteng, 2 is Eastern Cape, 3 is there's basically no node link in a sense in that being one of those. But then if you go to a ratio scale, that is the highest form where there's a 0 in the middle of the measurement. You know, if the next measurement is 1, that there's a definite meaning in what's the difference between 0 and 1 and those kind of things. So, and you can look at something like the temperature in degrees Celsius, because we know 0 is freezing point, below 0 it's negative, above 0 it's positive. So, and we know exactly what it means if it is 10 degrees Celsius versus 15 degrees versus 20 degrees. Okay, so that is nearly on that weakest to strongest scale. The mean and the median cannot be determined for a nominal scale of measurement. Okay, so I can't, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9 as the provinces, now suddenly take that and say, well, I get the average of that, and then suddenly everybody is in Northern Cape, because that is the mean if I just added all of that and divide it. So definitely this is incorrect. So you can't get a mean and median from a nominal scale. Quantitative continuous variables. Okay, so now we just need to remember what is quantitative continuous variable. So that is something like how long you have driven. So quantitative continuous variables result from measuring attributes of it, and that is correct. Ordinal scale of measurement is a higher level of measurement than interval. Okay, so this one is interesting because they are all part of the one concept, but ordinal gives have ranking in it. Must I explain C again? Oh, okay, cool. That's a nice one. Let's see if I can quickly copy that. There it is for you guys as well. Awesome, thanks for that. And there's another one coming, so I will also include that. Okay, so let's just on, I think the question, Jolene, was that on option B, C, or D, that I just explained that again for you. You can just type in which one, and I'll explain that again. Okay, so there is the reasons, B, okay. Okay, so there's also what they say around B, but so the mean median cannot be determined. So what we would have done is, for B, I would have had, say, the provinces. So one is, and let's just take 3 provinces. One is Gauteng, 2 is KZN, 3 is, say, Western Cape. So that would have been my distribution. But if I take the mean of that, or the average of that, it is going to be 2. So I can't say on average people are living in KZN. Okay, so that's just nearly nearly trying to explain that we can't get a mean and median from a nominal scale, because we actually working with other data. If it was height or if it was something else, then it's easy to get the mean and the median. But because we're working with categories, we can't get mean or median. So it's nearly the same to say you reading 3 newspapers and then you say, but what's the average that you're reading? And then suddenly the average is one of the newspapers. So it's not, it's different if it was in Gauteng there is 3,000 people. In KZN there's 2,000 people. What's the average of the people? Because then we would have added the numbers. But here we are looking at categories, so we can't do that with categories. Hope that explains it a bit better. Okay, on the difference between the ordinal and again why it is like this. So when you look at the lowest form, nominal, that is just like what we've done now. There's 9 provinces. We don't know what's happening within the provinces, so it just have numbers. On ordinal scale, so first year at UNISA, second year at UNISA, third year at UNISA, that's nearly an order. Interval scale tells me also within that order, there is a reasoning behind that order. So and the easiest nearly to look at that interval is to say, if I am 1, and yes, we know kilometers is also a measure of continuous, but because we are at interval, it is nearly, I live 1 kilometer from that place, you live 2 kilometers. So you know 1 kilometer, 2 kilometers is a kilometer further. There's actually meaning in that 1, 2, 3, 4. And then ratio is the one that I just talked about, the temperature one. But interesting, the temperature one is degrees Celsius, we have a 0, but the American system of, what is it, degrees of Fahrenheit or something like that, actually don't have a negative. But let's just, so ratio basically means where there is a 0 in, you can go negative or you can go positive with that as well. Okay, so that one was the incorrect one. And so I'll share this as well later on, that we have the notes linked to this question as well. I'll see if I actually add a new sheet just to have that separate as well for you guys. Okay, quantitative discrete variables result from counting, and again that is correct. Okay, so basically we've now done the 3 types of questions that you will can get from study unit 1 in the exam. So let's see if there is more. So I'm first going to move this to the end. So if we have time, we can look at that one, so that we get through all of the things that we want to get through. I think it's going to be a difficult, but let's see. Okay, so let's look at this one. I think there's a few that I have on this. So if the interesting one is also, I want to see, I don't have a stem and leaf. So if somebody have a a stem and leaf that we have as an image somewhere, you can post that in the chat as well. Then we can look at that as well as an extra one. But let's first look at what we have.
Jean, can you hear me?
Okay, so consider the following cumulative frequency distribution. So cumulative frequency. Frequency distribution of distance from home to school for a sample of 50 grade 7 learners. Okay, so we've got cumulative frequency, but let's just add other things. Let's just add. So if you look at things that are missing here is frequency. So I'll just add frequency because sometimes there is questions on frequency. So the first one is always, yeah, let me quickly, while we are at it, let's just check. If there's a setting that I just want to check if there's a setting to see if I can, why you guys are muted. It's weird. Okay, yeah, I will need to check why this is happening. Because there is definitely something wrong with this at the moment. Okay, so how we get frequency? Remember, frequency is nearly where we start before we get to cumulative frequency. So to get that number, we take the cumulative frequency and we subtract the previous cumulative frequency. Okay, so it will be 17 minus 4. Okay, so if there wasn't a stem and leaf in your assignments, okay, I will make a note. We need to cover that because then it is a big possibility that will be in the exam. Okay, cool. Okay, we will cover that. Okay, so then 42 minus 17, I think that is 25. 48 minus that is 6, and 50 minus 48 is 2. So then I just want to add again that 17 plus 8 is 25. 25 plus 25 is 50. Okay, cool. Let's just do that as well. Okay, so cumulative base with frequency, and have you built in the formula to do that? So this is one that I can add to Excel. So I'll add that to Excel. I didn't even realize we can do that. Then relative frequency and percentage frequency. Okay, cool. So here's a nice, so this is nearly what you need to use to answer these set of questions, because it is very difficult from just looking at these and having that to answer all the questions. Okay, so the percentage frequency of class 9 to 11. Okay, and there it was also worked out. But basically, how you get it is take the 13 divided by 50 as a percentage. So that would give you 26%. Okay, their answer is 34, so that one is incorrect. Okay, so this one was, in a sense, easy. The first one was the incorrect one, but it can be also in your exam shifted around which one will be incorrect. So let's just look at the other question. So the midpoint for class 5 to 8 is 7. So what is between 6 and 8? It is 7. So that one is correct. The relative frequency of class 18 to 20. So if you take relative frequency, it should be 2 divided by 50 as a percentage. That will give you 4%, or as a relative frequency, sorry, it will give you 0.04. And that's why I like this table, because now you can see the differences if I give you different types of questions. Okay, so this one I'll also build for you, that we can just get something like that if it is in the exam. The width of each class, so how we do that, and I think this is sometimes nearly a catch, because what we want to say is 20 minus 18, and that gives us 2. But it is actually all values from 18 to 20. So it includes 18 and it goes up until 20. So it is actually free. So this is the difficult one, because you always want to say, well, 18 minus or 20 minus 18, it's 2. 17 minus 15. But look at what is happening here is the values of between 17 and 18. Okay, so what happens to that value? So that value is then also part of cool, I'll copy this as well. So that value is also part of the calculation. So it's not that, let's put it there. Okay, cool. So that is a nice one also to have, because in some of the questions they've asked the width, some of the questions they ask the number of classes. So again, this is a nice one to have with you, so that you can, because this question I know varied across with 3 or 4 different question sets that was asked in the assignment. Then the frequency of class 15 to 17, so that again is just looking at that frequency, so that is again correct. Okay, so the incorrect one was option A. Okay, so this is nearly, if you look at the frequency distribution. Other things that they can ask is, and we'll get to it, the box and whisper, but that is more to do with chapter 3, because yes, D was correct. Okay, and the reason why D is correct is the thing that they should have added here is, so distance in kilometers, 6 to 8 kilometers. So it is 6 kilometers, 7 kilometers, and 8 kilometers. Then how far are you from school? 9 kilometers, 10 kilometers, 11 kilometers. So it's those 3 readings. So your data set would have been something like 6, 7, 7, 8 for that one, because you had 4 of them, but it could have been 6, 7, and 8. So that is why the class is 3, because you actually start at 6. So 6 is a option. So that is why 6, 7, and 8. Okay, if it was only 7 and 8, then the class width would have been 2. Okay, so it is distance in kilometers. You include the 6 and you include the 8. So that is the reason why we have that. Okay, so if I said upwards from 6 or something like that, see, the thing with the formula here is, because what sometimes happen is sometimes we use this as well. So if it was, so I'll just check that formula for you as well. If it was something like this, then it would have said you include 6, but you don't include 8. But if it was those 2 brackets, it would have been 6 and you included 8. So I will just look at where I can get a better definition of that one, so that when it includes both ends, what you need to do, and if it excludes the one, what you need to do. Because this would have been for the one where you have all the top or the bottom you exclude actually from your calculation. Okay, because normally we have this on more continuous data, so that you normally, and that is what I thought first as well, that where you would have had something like that, and your next one would have been 8 to 11, so that it goes up until 8, and then all of the values from 8 to the next one. But this is on discrete, so I don't even know if I save it. So you can see this is in pure kilometers, so they don't take 6.5 kilometers or 8.5 kilometers. It is 6, 7, or 8, 9, 10, or 11, 12, 13, 14, 15, 16, 17. So every time you can see there is that free intervals or the class width. So let me check if there is somewhere that we can just get the split between when things are included and not. That I can just get that for you. So I'll just make a note for myself here that I need to look at that. Okay, so that we can incorporate that in the formula as well. Okay, so let's go. So basically what we've done so this was nearly one question on chapter 2. So what you will see also in the exam is that on chapter 2 they nearly like to incorporate chapter 2 and 3 together, so that you will get a question or two on how you nearly look at the measurements that we've done in chapter 3 as a visual representation. So you will see here's a lot on this one, on Q1, the position, and what we will also work out the value. Then there is questions on mean, median, and mode. So we will definitely go through this one as well. And then they talk further on other things. And this one, I think we will see if this one we will use the calculator again. And then we get into some other things. But let's first look at this question. So nearly they give you a table. So this is now interesting, because here they look at that values that they've talked about. Now they give you certain other values in between. Interesting. So that was the 4. So here was actually distances as in 6.2, but we didn't know it in that instance. So again, if you have different data sets, you can see different things from the data. Okay, so here's another one that I am going to copy in for you. I'll just put it somewhere there. Okay, so because I think what is important from this is that set of formulas. Okay, so we'll cover that as we go along. Okay, so let's quickly, so you get the set of data, then we start asking you a lot of questions, and we're asking incorrect. So again, incorrect. So the position of the first quartile, so we want to look at Q1. Okay, for Q1, and here's the nice formula, it's n plus 1 divided by 4. So from this formula, just you could have had 1 in front. Okay, so you could have had 1 in front just to make it easier for you to, 1 goes with quarter 1, 2 goes with quarter, and here is, okay, so that, just check your formula. So you would have done your formula correct, but that must just be a 3 to go with quarter 3. But your formula within the Excel would be correct, because that is correct. Okay, so position of a first quartile is 13. And the reason why 13 is there is a section within the study guide that they want you to round it off. And that is nearly one of the confusing things between some of the study guides and some of the books on the methods that you need to use, but the study guide is clear that you round it off. Okay, so quartile 1 is 13. The position of quartile 1 is 13. Okay, but let's look at, so here we have position 13. So if they ask us for the value of Q1, it would have been 11. Okay, so just if I ask us the value of Q1, it would have been 11, and I don't know if we do that in the next, no. Okay, so just also that difference between the position of Q1 and the value of Q1, because to be honest, they love to ask that. So it is nearly, I've seen that in a lot of the exams, it is one of the questions. And they like to nearly trick you between the two. Okay, it can even be that what they do in the exam is that your distance nearly is also 13, and then for Q3 it is something different, and then you get confused with those questions as well. But from here, the value of Q1 is that 11. The position of the second quartile. Okay, so the second quartile would have been 2n plus 1 divided by 4, and that would have given you, so now look at Q2, so that is also the same as your mean. So that's another one that you can nearly bring into this. It is Q2 is also your mean. Okay, and then your mean is very much basically looking at the formula that you have for your mean is n plus 1 divided by 2. So for n plus 1 divided by 2, we will get the value between those two, but you can now see nearly that whole range of values is 12.5. So the value again is 12.5. So here, it's not the position that is 12.5. The position is 25.5, but your value is 12.5. So that is where they wanted to catch you out. So your value is not, your value is 12.5 and your position is 25.5. Okay, second quartile is calculating the average between that and that. Yes, because that's also the mean, so that is correct. The range. So the range is your highest number minus your lowest number. Okay, so the range 20.2 minus 6.2, it is 14. Okay, so the range is definitely correct. The position of the third quartile, so when we look at that formula, it will also just divided by 4 just to make it a bit clearer again, and that is your position. So if I ask for value again, the value of that for Q3 would have been 14. Okay. Yes, difference between range and interquartile range. So, and let's look at this one. So your interquartile range is the difference between Q3. Okay, so if there was a question around interquartile range, it's basically what's the range between the two quartiles. Okay, so that would have been the value of 14 minus the value of 11. So your interquartile range would have been 3. Okay, so just if anybody else looks at this, your interquartile range would be 3. Okay. So thanks for that question. What else could we nearly get from this? So you've got they can ask minimum, they can ask maximum. So they nearly cover that to ask minimum and maximum, they cover with a range. You've got so what they can also have said, but we'll probably get to those later on, is to look at mean, median, and mode. They normally don't, when they look at quartiles, they normally look at quartiles on its own, but it can be that we nearly combine quartiles with mean, median, and mode, but I haven't seen that in quite some time. So they normally split it out, that if I ask you a question on quartiles, it will be something like this one. Then they normally throw your mean, median, and mode into one as a question as well. Okay, so let's look at quickly question 3 again. Option E. So the position of the third quartile. So the third quartile, we basically have, to get to the position, we use the third quartile formula. So remember, n is 50. So 50 plus 1 is 51. 51 times 3 divided by 4 gives us 38.25. But again, with quartiles, we need to round it off to the nearest number. So the nearest one would be 38. So that is why then on position 58, and they're asking us for position. So position is 58, which is correct. But if they ask us for the value would have been 14. Cool. Okay, let me just save this as we go along. Okay, so then the next one. Okay, so interquartile range, we did there. It got us 3. That was actually the first question. So that is correct. But and what I don't like about this nearly is that you don't really, when you in the exam and the question is structured like that, and I assume it was like that in the assignment as well, you don't know what that previous things that you worked out. So if you didn't have it on paper, now suddenly you don't remember what was Q1 and what was Q3 again. So now you need to sometimes work it out again. So this is the part of the exam that I really don't like, if they have a follow-up question. But I now remember Q1 was 13, Q3 was 58, the mean was between, or the median was between those two. Okay, so interquartile range, as I explained it in the previous question, it is your value of Q3 minus your value of Q1. So that is 14 minus 11, which is 3. Okay, so that is correct. There is no mode. I nearly automatically want to say no, because there will be, in a data set like this, there will always be a mode, and it nearly, so let's go from the bottom and see. So there already we have two variables or two numbers that could be the mode. They don't ask us what is the mode yet. They don't ask us, but that is a mode already, unless there's one that has more. So there's another one that it could have been 12.2. There's another one, so it could have been multimodal. Okay, so that is going to be your mode. 12.5 is going to be your mode. There's 13 that's repeated a lot, but 12.5, there's definitely not going to be one that is more than that. So, and remember, mode is the one that appears the most. So there is a mode, and that mode is 12.5, just if we need it somewhere else. Okay, the median, the median is 12.5. We've calculated that. Okay, the mean. Do they give us the sum of all observations? Okay, so they give us that. So you don't need to go and say 6.2 plus 6.4 plus 7.5. They give us the sum. They give us the sums, let's say, of x is equal to 6 to 6.6. So to get the mean, it is basically that value divided by 50, the number. Okay. So it's 6 to 6.6 divided by 50, which gives you 12.5. Okay. Okay, so 12.5 is the mean. So if we have the mean, median, and mode that is all the same, then we know the distribution is symmetrical. Okay, so that is then also correct. So, and I'll share that diagram and it's somewhere in the book as well. But you basically have the mean, median, and mode all equal, then it is a bell-shaped curve, and it is perfect normal distribution. Okay, so it is then definitely symmetrical as well. Okay, so again, you nearly can now see they use a table that they would get out of chapter 2, and then they can ask you nearly all of the questions to do with chapter 3. So we've got positioning, we've got mean, median, and mode. So then obviously the next one nearly is to say, well, so we've got mean, median, and mode. Then I would think they will ask variance, standard deviation, and that is then what they do. They ask you nearly population variance, sample variance, population standard deviation, sample standard deviation. Okay, so that is the things that they ask us. So let's again look at this, and nearly I'll try to give you a hint or two on this one, how I would have looked at it. Okay, so incorrect. So we can, and so let me, another note for myself. I'll do do an Excel for this one, because we can add all of these numbers in an Excel spreadsheet, and I think Christina did that as well, to get to, yes, cool, to get to an answer. Okay, so we can do that. We can put in all the values in, and then we can also look at the formulas. So what she did was basically to use the formulas as a tool also in Excel. Okay. So we can put all of that into a spreadsheet. So I'll do the data. So again, I just made the note for myself. So we'll just create a database from position 1 to 50. We put in the X numbers, and we can use Excel formulas to calculate this, but also good to have this set of things to use. Yeah, so I'll do the other one that we put in the raw data, but it can be that they also in the exam just give you that number, and you need to work it out. So it can be that in the exam they don't even give you the data. So I will do that for you. So if we do it purely the way of the formulas, very, very simple to get to that. I think they give us the formula page in any case, but I want to show you something different as well. So I look at this before I get to the formulas. Well, at least now we will set up the formulas that you have everything. But in the olden days when we haven't had access to Excel, pre-COVID, when you did the exams, so just look at that one is population variance, and that one is population standard deviation. So those two are linked, sample and sample. So those two are linked. Okay, so if I look at the sample, so your sample standard deviation is equal to the square root of the variance. So let's look, it is 8.293. So my S needs to be 8.293, the square root of it. So if I get that, it is 2. And let's round it off, 880. Okay, so then I know, because that works out, that my sample and my standard deviation, the sample standard deviation is correct. Okay, so then we do the same for the variance. So again, the variance, the standard deviation is the square root of the variance. So the variance is 7.127. So if I take the square root of that, 7.127, I get my answer as 2.66. Let's just see if I round that now off. 670. Okay. So now I see there's a difference in those two. So I would have then said, okay, well, I only need to go and investigate those two. Because then I don't need to, one of those two is wrong, because else they should have worked out as that one, because we are only looking for the one incorrect one. Okay, so if it was the other way around, that we were looking for the correct one, then again, that would have been correct, that would have been, so then again, we would have said, well, one of those ones is not the right one. So now I know at the population variance, I have the mistake. Then I can go to my population variance where I still need to use that. So your population variance, I think the formula is as simple as that divided by 50. 406.369 divided by 50. Yes. Which is 8,127. Okay, so then we see that, okay, not 7, so 8,127. So we see that it is option A that is wrong. And then if we have then taken that, it would have given us 2.851, which tells me that one is correct. Okay, so nearly, but I will create the two formulas for you and the data, so that we can just work from that as well. Because again, on a big data set like this, they will give you that squared deviation. They won't expect you on a big data set like this to actually work with Excel, because again, not everybody have Excel. You don't have always access to it. To ask you to put that into a calculator, they will also not do, because that just creates so much havoc when you need to put that into a calculator. But again, the formulas are there to use. We will get a formula page as part of the tables as well. That way, yes. So A is the incorrect one. Let's just use a different color for this one, because there's so much scribbling on this one. Okay, cool. Okay, so now we've basically covered the measures of central tendency. We've covered the dispersion. So the extra one that they've been using and asking that for some time now, since we're doing a lot of online exams, is that they ask you the coefficient of variation. Okay, this is a nice color. It's that is gonna definitely not work. Okay, so coefficient of variation. Again, I think I did do this in Excel, but we can do this in Excel as well as a formula. So coefficient of variation. Cool. So let's do that. And with this one, you see that they give you the data. So for coefficient of variation, what you need is your sample standard deviation and your mean. and then you multiply that by 100. But so the mean is easy to calculate. It is basically looking at VAT values, you add all of them together, and you divide by n. So that is your mean calculation. So it is, your mean is basically looking at your sum of x divided by n. Okay, so, and that will give you the, let's quickly see, the 107.4. So if you only worked out the mean, that would have been what you would have said is your answer, but that is not correct because we still need to work out the standard deviation. So what is interesting, so there is no easy way nearly. So you needed, if you didn't use Excel, you needed to say 100 minus the mean of 107.4, square root of that, plus now 104 minus 107.4, and the square root, and we do it for the rest of the values as well up until the last one of 112. Okay, so that you should have been done if you didn't do it in Excel by hand. Then to get to the, so that would have been the variance. And then we still need to basically take the variance. Okay, so we then, that answer we would have square rooted. So that answer was 26.8, and we would have square rooted that to give you 5.177, which is also one of the answers, but that we wouldn't have known out of a calculation. Okay, so then that goes on the top, 5.177 divided by, so 5.177 divided by 107.4. So that gives us 0.0482. But remember, we need to multiply that by 100. And that then is 4.820, which is that one. Okay, so that is your correct one. Okay, so there's, let me think, there's no other way nearly to do this. There's no shortcut. Only if I have given you maybe that information, then it's easier to do, but else you need to use or Excel, or you need to write down a table for you and work it out with your calculator. There is no shortcut in this one nearly to get to an answer. Yeah, the one thing that, again, that you can be sure of is they won't give you a data set like this and ask you to work out the coefficient of variation. There's no ways. So it will be a small set of data, but again, I have made the note that this one we can put into Excel. So again, I will create it as after this session. I will create a few sheets, and as we go through through the sessions, I'll just add. It's the same that you will see. This will become one massive document. So I'll just, what we don't finish today, I'll just add next week's stuff that I want to do, and we just continue. And this will also be just become one massive document that I'll load and share as well, that we just have everything into one, and you guys don't have to jump between all the things. What I will also create for you, I just want to make a note, is I just put all of my notes into a summary pack, but this is just for myself, that I just make, that you also, that everything is in one, that when it comes to the exam time, that you nearly have everything together, that you don't need to worry about that. Okay, questions. I think everyone is muted, so if anyone can chat, you can unmute and speak, but I think there's something in the setup that has gone a bit haywire since we chatted last week. Any questions thus far, or can we continue? Okay, so let's continue then. So this is an interesting question. So which one of the following summary measures is not used in the 5-number summary to summarize data? Okay, cool. So let's copy that. No, please continue with that spam, because sometimes there is a nice, so let's just do that, a nice answer. So again, this was actually from the Prescribed book. So, and this nearly leads into the next questions of the box and whisker, the box plot. So it nearly leads into that. So what we have here is, so let's say that is your smallest number, that is your maximum number. So your 5-point summary has the minimum and the maximum. So let's see minimum, maximum. Then what it also has is the box. So that's why we get into that in the next one. And this box, if that is minimum, this box represents Q1, Q3, and there will be a line somewhere that represents Q2 or also the median. Okay, so this is how, so this is your 5-number summary that we do, but this is also actually called the box plot. And in some instances, they call it a box and whisker, like in a cat's whiskers, because that is apparently seen as whiskers. So just imagine it, please. Okay, so the one that is incorrect and is not part of this is the coefficient of variation. Okay. So again, here we have smallest, Q1, Q2, Q3, and largest. Okay, so that is nearly just leading into the next set that we are going to look at. So what I've done also is I've included 2 of the options that was in your studies or in your assignments. because I just want to nearly work through both of them. The big catch nearly with some of these when they look at the data is, and it's very easy to make that mistake, is that we say, and I haven't looked at the data yet, but we say, okay, say that one is correct. And then suddenly we say, oh, A was correct, we pick A. This, and trust me, this happens a lot because you're so much rushed for the exam, you need to get to the next question, but when you get it wrong, and you're like, but I know that was correct. But look at what was A. It said box plot D. And trust me, this, when you're in the exam, just as you go through it, just check if A corresponds then to the A that you think is the right one. Because I've seen it too many times. And again, when I went through this the first time, I also made the same mistake because it was so much pressure, and you look at, let's see which one is correct or not correct. Okay, so that's just nearly a tip when in the exam, just make sure whatever they're referring to in the answers is also the correct one. Okay, so there's another one in Excel. Sheesh, I didn't even know that one can do this in Excel. So let's see. Okay, so basically you used a chart and you then created. So I'm just going to make it very small. We can later on. Okay, so how I would do this in the exam, and how I normally look at this is to say, well, we've got that. Okay, so we know that the smallest value is 115. Okay, so let's look at where is the smallest value. So 120, 100. So your smallest value is probably sitting there. Okay. So if that is the smallest value, 100 can't be my smallest value. So box plot A can't be my smallest value. 80 smallest value, no, it must be 115. So box plot B can't be your smallest value. 100 smallest value, sorry, box plot C can't be because we are looking for 115. Box plot D, also around 80, can't be. Box plot E, that might be the smallest. It looks in line, so that might be. Box plot, so box plot E might be. Smallest number, that is between 80 and 90. Okay, can't be box plot F. So without looking even at the rest of the data, that is the only one that it can be. Okay, so then, yes, we can look, okay, so that is probably sitting between 120, 130. So it tells me more. The 120 is in the middle. So we know that that is the median, or Q2. The Q1 will sit between those two, so it is the same. That is why there's not a whisker part, because Q1 is also sitting there. Q2 125, it looks like Q3, sorry, so that looks like Q3. Okay, so without nearly going into all of that calculation, by just visually looking at added, we had the answer. Okay, so that's why I actually added another one with, it was the same question in your assignment, but with different, and let's just see if I can make this a bit bigger, because I don't really want to even go into, let's see. Ooh, why didn't, So let's then do this. Oh, okay, so I can't even do that now. Okay. That's quite weird. Okay, so let's just do that. Let's make it a bit bigger. Okay, so let's, okay. So just to quickly go through this one, this the same principle nearly as the previous one. Okay, so the data was different. Okay, so minimum 100. Okay, so let's look at, okay, minimum 100. So that box plot A could be one of them. Okay, so let's look at, it can be one of them. Minimum 100. Okay, so that is sitting at 80. Box plot B can't be. So let's just see, box plot B can't be. Minimum sitting at 100. Okay, so it can actually be box plot C as well. Minimum sitting at 80, so it's not D. Okay, that minimum, sure, what is that going to be? 100 and something, so it can't be E. Minimum must be 100, can't be F. Okay, so now we sit with basically A or C. So then I go to maximum. Okay, so this one wasn't as easy to eliminate. Okay, can be A, still A, can be C, still C. Okay. The next one that we look at then is to say, okay, what we need to get to Q1 and we need to get to Q3. Okay, and that is the median. So let's first get to the median. Median, all right, so it's still the possibility of A. Median, right, still a possibility of A. Okay, so this one was a bit more, so we actually needed for this one to go through all of the options. So unlucky if you had this one in the assignment. Okay, then Q1 is 110. 110, so it can still be that one, can still be this one. Yo. Okay. Q3, so here we can see that is the difference. Okay, so your Q3 is 120. So let's see here, they say 150, so it's still part of that. So your answer is then box plot C. Okay, was Excel actually wrong in this one? But okay. See, so what Excel does, and that is the difference. So Excel uses the strict rule that it would have been exactly in between the two numbers, where we use the rule that you round it off to the nearest number. So for Q1 and Q3, just be very wary about it was like in where was that one that you also so it literally takes those positions. So Excel, there's no rounding off or making it easy or anything like that. Okay, so that's a big difference between Excel and the study guide as well. And yeah, so just be wary about that, specifically when your data is a small set of data. Okay, so basically here this was a much more difficult one than this one, where it was actually very simple to eliminate and get to the right answer. So I think this is quite, hopefully if you're in the exam you get the one that is just the easiest to eliminate. Okay, so that is box plot. The one that is not in here, which I've also just want to make a note of, is stem and leaf. But in the next session I will get you a question or two on stem and leaf, because there wasn't one in your assignments. So I just want to make sure that is also covered for you in the exam. So I will make a note. I've just now made the note that we just cover stem and leaf as well. What else was? Let me just, I go through this. So that's fine. That's fine. Basically covers all of that. The other thing that I'm just looking at what could have been in study unit. Cool, Tembi. That is brilliant. So now I like that. So in the exam, if you get it, great. The other thing that I just want to add here, that I just want to see if I can get a question, is the distribution shape. Because I don't distribution, I'm just writing again notes for myself. I haven't seen in your, just in that one question where they had where was it, the mean, median and mode symmetric. So I just want to add one question where if it is a positive tail or skewed to the left and skewed to the right, that we just cover that as well. So I'll just look for a question on that as well. Okay, so then let's go into study unit 4, and again we'll just see how far we go. We still have about 25 minutes. There's a few questions left, so let's just see how far we go. I just want to make this again bigger. This is not really working this small. Okay, so you can see it from one of the ones that you guys sent me in the WhatsApp, so it's a bit blurry, but okay, let's get to study unit 4. So I think the important thing with study unit 4 nearly is and let's see, okay, so here's the important concept. So independent, mutually exclusive, complementary, we'll get to that. Okay, just want to see what else is in. Okay, so let's first nearly cover those aspects. Okay, this is quite an interesting question. Okay, so the total is 800. So we need to fill in totals. So first, 168 plus 240. So that one is 408. Okay, so that will be 392. So let's just check. 160 plus 112 plus 48. Oh, it's not. Okay, so that is actually not 0. It has a value in it. I just want to add that again. So it's 160 plus 112 plus 48. Okay, so that's 320. Okay, so that already is where they would have, where I would have maybe made a mistake if I didn't check that. So that must be 72. Okay, so I thought they left it out because it's a 0, but it is not. So if you add those two, it is 400. If you add those two, it is looks like 280. And then that is 120. Okay, so there already needed to say you needed to complete that one, and then you needed to add the totals. Okay, so we needed to add the totals before we actually could have done anything. Okay, so then before I get to independent and mutually exclusive, I normally look at the easier ones first. So if they ask us something like, oh, how did I get 72? So basically what I did is I know the total is 800. So 800 minus all of the other ones give me the 72. So they at least need to give you the total of 800, else you wouldn't have known what to do there. Okay, so if they don't give you 800 as the total, then I would have then said that is 0, because I don't know what the total was. So because they gave you the total, that is how I worked that out. So that is the missing values. Okay, then I normally skip the independent and mutually exclusive. I just want to make the other ones because that's normally easier. So if I say something like, what's the probability of learners that are less than 3 kilometers from school, or what's the probability of somebody being in high school? That's a much easier calculation. So let's look at the probability that a random chosen learner is in high school. Okay, so being in high school, we don't worry for that question how far the person is from school. So we just want to know if he is, or if the student is in high school, or the learner. So high school is basically looking at what's the total of high school? That's 320. How many students are there? 800. So 320 divided by 800, that tells me what's the probability that the learner is in high school. And that is 0.4. Okay, so the probability that the learner is in high school is 0.4. So the proper, if you used the 48, it is including the less than 3 kilometers, yes. So I'm now looking firstly at option C, option E. Okay, so that for me is the easiest one. So also if it was just less than or going down, that would have been an easier one for me to look at as well. Okay, so let's look at question B. The probability that a random chooser learner is high school and less than. Okay, so how I also do this is to make for myself easier. So they're asking us high school and less than 3 kilometers. So I like to do it this way. So it's high school and less than. So then I know it is where the 2 crosses, and that is 48. And again, the probability of it being randomly chosen means that we divide by the full 800. Okay, so that will give you the 48 divided by 800, which I assume will give you that 0.06. Okay, so that was also correct. We are again looking for the incorrect one. Okay, so if they ask us to look at what is the probability that a random chosen learner is in primary school and that he is greater than 6 kilometers away from school, I would have done that, and then I would have said, okay, so now it is 240 divided by 800. Okay, so basically, if you get one that will ask you the probability of one with another one, it's always easiest for me just to then say, okay, look at primary, look at the other one. So where the 2 crosses, that's the value that you use. Okay, so those 2 sorted out. Okay, let's look at mutually exclusivity. Okay, so mutually exclusive events means that only one of it can happen. So events, primary school and high school mutually exclusive? Yes, because you can't be in primary school and in high school. You can only be in one of them. Okay, you can't be, so that is mutually exclusive, the school level, but the distance from school is also mutually exclusive. You can't be 3 kilometers from school and 6 kilometers from school and 9 kilometers from school. You can only be one of them. Okay, so distance from school would also have been mutually exclusive. Does that make sense for mutually exclusive one? So it is either or, you can't be both. Okay, so it is, you can't be, say you're living in Gauteng and you're living in the Western Cape at the same time. There's just, you can't. Yeah, so the mutually exclusive one is nearly one or the other one. So that one is correct. Okay, so let's look at the events less than 3 kilometers, between 3 and 6, and greater than 6 are complementary. Okay, so this is nearly, in a sense, a catch, because we normally have it as two things. If I know the probability of A is 0.6, I know that the probability of the complement of A is 0.4. And how did I get to that? Basically 1 minus the 0.6. So the complement is always the rest of. So if that was 0.6, the probability of A, the probability of not A is 0.4. But we've always just seen it in the instance of two variables or two numbers. So here we are going a bit further. So events less than 3, 3 and 6, and greater than 6 are complementary. So if you're not in the one, you're in one of the other two. If you're not in those two, you're in the other one. The only difference with this one is they use more than one variable. So again, nearly to say, if we had eye color, you have blue eyes, you have brown eyes, or you have green eyes. So if you don't have the one, you have one of the other. So if you're not in that one, you are in one of the other two. So that is nearly saying complementary, is if you're not in the one, you are in one of the other. Okay, sorry, this, I just need to watch this WhatsApp. This is important because this talks about load shedding, linking that to what the guys are facing on the exam portals. It is okay. So just to inform you, there is possibility of load shedding coming our way. Wonderful. Okay. So we've still got a few minutes before maybe we lose power as well. Okay, so that is complementary. So let's look at the other one. Events high school and less than are independent. Okay, so let's see, where can I create some space for me? So let's do that. So for something to be independent, the probability of A times the probability of B needs to be the probability of A and B. And I just want to make 100% sure now that I am using that formula right. So probability, if somebody can just check that for me, independence, probability A times B, yes, okay. So that is your formula for if you want to check if something is independent or not. So let's look at what is the probability of high school. We've seen the probability of high school was that 0.04. 0.4. What is the probability of less than 3 kilometers? So that less than 3 kilometers probability is 120 divided by 800, which is 0.15. So if we multiply those two, 0.15 times 0.4, we get 0.06. Okay, and we actually have worked that out here also as 0.06. So we know that it is independent. And here they say it is not, so that is why A is wrong. Okay, so it is actually independent, and that is why we have option A as being incorrect, because it is actually dependent. So are you happy with that? So I think what is important here is that we need to remember what is the independent one. What's the formula for that? What's the mutually exclusive one? I think we'll get to nearly the conditional ones in the next question. So I think that will be done there. Okay, so let's just, I've missed that. Any questions or thumbs up or happy with that? Is it less Greek? If I can put it that way. Christina, hopefully it is less Greek than normally. Yeah, can we do more, please? I think we need to do more. So let's do this one, and now there's 5 minutes. So let's end off with this one. But I want us not to just answer that question. I want us to do more than that. So just okay, for this one, the option was B, so let's just put that in there. Okay, so actually what they did and I'll include one or two other for next week as well. I think it's important that we still have time, so we still have a month to go. So rather finish with the next question, and I'll add more on probability that I think it is important, because nearly out of study unit 1 to 5, that covers half of your paper, which should be the easier ones to cover. So I want to make sure nearly that you get this right. So I'll add 1 or 2 more tables to this, that we can cover that next week. Also, out of study unit 5, that is probably one of the study units that you will also get 3 questions in the exam, because that will cover the Poisson binomial and your discrete. So that normally also there's 1 question on each. See, I think what is important with study unit 4, the probability, is they make it difficult, but it's nearly also to sometimes see if something makes sense. So let's look at this question and what they asked, because I think this was one of those that they said you need to look at something that is chosen. So calculate the probability that a randomly chosen learner is either in primary school or travels more than 6 kilometers. Okay, so this one is not and. So they're not asking us to say, what is the probability that this learner is in primary school and is greater than 6 kilometers? Because then it would have been just the 240 divided by 800. Okay, so it's not that. So it is, what is the probability that the learner is in primary school or is greater, I'm just going to say greater than 6 kilometers. Okay, so let's just quickly, again, I hate this because now you needed to add all of that again to get the 480. You needed to add all of that to get to the 400. Okay, so what's the probability that the learner is in primary school? Okay, it is the 480 divided by the 800, or that the learner is 6 kilometers away. So 6 kilometers, more than 6 kilometers away from school, that is 400 divided by 800. Okay, so what you will see is now suddenly we have 880, so we have more than one. Okay, so and that can't be. So you can't have a probability of more than one. So what in these two am I adding twice? So within the primary school and within greater than 6 kilometers, that value I am adding twice. So you can see I'm adding it in there, the 240, but I'm adding it in there as well as 240. So basically in this calculation, I have doubled the 240, and that is wrong. So I need to take away one of the 240s. Okay, so the 240 is included there, the 240 is included there. It is not correct to do that, so I need to take one of the 240s away. So if I take one of the 240s away, it will be 880 minus 240, which will give us then 640. So let's just do that calculation again. 480 plus 400 minus 240 is 640. And 640 divided by 800 gives me 0.8. Okay, which is option. Okay, so when we do the OR, it is important that we nearly need to subtract the AND. So we need to subtract the AND so that you can get your answer. Okay, so nearly from where we were in the previous one to this one, I think now it's Greek again. Am I correct? Because this was now nearly a different way of getting to the answer again. Okay, I thought so. So and I think that is nearly where a lot of the confusion is with study unit 4. It's nearly with all the possible questions and the different types of probabilities and what you need to do if it's this one and what you need to do if it's another one. What do you need to subtract? What do you need to remember? So what I will definitely do is that I will add another one for study unit 4 that we need to cover more, so that we include a bit of writing as well, where they give you probability of A is 0.6, probability of B is something, and we need to calculate. So I will definitely we need to include a lot for the next study unit or next session, that we just continue with study unit 4. So I will definitely do that. Okay. Sure. Okay, that was 2 hours. That feels long, but it also feels short. So next week I'll just continue with study unit 4, and I'll just add to this that we just continue with that. Okay. If any of you are writing any exams in the week, good luck, and we'll chat again next Saturday this time. You can still post a few questions if you want. I'm just stopping the recording, but you can definitely